Hello and welcome to this episode of the Industrial Engineering Notebook. Today we'll be talking about factorials, permutations, and combinations. So these come in handy. They're just nice to have in your back pocket, especially when you're dealing with probability problems. If you don't have a good understanding of factorials, permutations, and combinations, you can get really lost really quickly. And really, these center around one central question. If you can answer this one central question, you'll understand all three of these things. And that question is, real simple, how many different ways can we do that? And we'll start with a real general example here. Let's say you have some spots to fill, and these spots happen to look like rectangles that look like these kind of like marshmallow looking kind of spot things. And let's say you got 4 spots to fill, and maybe there are 3 ways to fill this first slot. And let's say there are 4 ways. I bet there are 4 ways to fill this second slot. And then I bet you got 2 ways going on here. And this looks like a 6-way kind of spot. Okay, so there are 3 ways to fill this one, 4 ways to fill that one, 2 ways, and then 6 ways. And then we ask that central question, how many different ways can we do that? Okay, well, you have 3 ways, and then for each of those 3 ways, you have 4 more ways to fill in that spot, so 3 times 4. And of the 4 ways you did here, of the 3 ways you did here, you have 2 more ways, and yep, it's just multiplication. So to answer how many different ways can we do that, you start multiplying. 3 times 4 times 2 times 6, and this gives you 144 different ways. And this is pretty general. This will help you in pretty much any problem, but you're probably still looking for some practical applications here. So in a word problem, this might come out as dealing cards, right? Like you're going to deal 4 cards, and it could be one of these 3, then one of those 4, then one of those 2, and then one of those 6. It could also be designing a widget. Maybe these are spots on a widget, and you want to know how many different widgets are you going to end up with at the end. Or maybe it's writing work instructions, and there are 3 steps here, or 3 possible options here, and then 4 possible options here. So it can kind of vary, but this is general overview, how to answer how many different ways can we do that. Okay, now we're ready for some factorials. For this example, we're going to have 5 spots to fill. 1, 2, 3, 4, 5. Let's say you have 5 objects to fill in those slots. So we're going to make a little bag here, and I bet you got a star in this bag. You know what? I bet you got a triangle in this bag and a little circle right there. I bet you got this little trapezoid in your bag and let's say like a swirly kind of looking thing. Okay, so you have 5 slots and 5 objects in your bag here. And we're going to stipulate, okay, let's write that down. So you got n, oh, yep, that's right. We're going to represent 5 as the letter n. So you got n equals 5 spots. And you got, cross that T, don't forget that. N equals 5 and then objects. Now we're going to ask our central question. How many different ways can we do that? And we're going to stipulate here, there is no replacement. So once you put it down, you can't put it back in the bag. There is no replacing objects in your bag. No replacement. Next, we're going to say no repetition. You can't put 2 stars down. Why? Because you only have 1 star in your bag. You should have came with a different bag if that's what you wanted to do. And remember, the central question is, how many different ways can we do that? So for the first spot, without saying which one we're going to put it where, we know that we have 5 different options for that first one. And so you put one of those objects into that spot there, and then you're only going to have 4 objects left in your bag. So for this next spot, you're going to have 4 options. And then after that, you're going to have 3 options, and then 2, and then you're going to be left with 1 option. So without saying where we're putting what object, we know that we're going to have 5 ways, then 4 ways, then 3 ways, then 2 ways, then 1 way. So how many different ways can we do that? 120 different ways. Scenarios like this actually pop up all the time, and so there's a notation that you can use when you end up in a situation like this and you want to count the total number of different ways, and that is what's called a factorial. It's just an exclamation mark. This does not mean 5. This means 5 factorial. Okay, permutation time. For a permutation, all we're going to do, the only thing that's going to change from that last example that we did, is we're just going to knock down the number of slots we have and keep the same number of objects. So you still have n equals 5 objects, and instead of 5 spots to fill, you have r equals 3 spots to fill. And then we're going to take a look at this. Just like we did before, how many different ways for this first spot? Well, I see 5 different ways. And how many different ways for the second spot? Well, 4 different ways, and then 3, and then nothing. So 5 times 4 times 3, 20 times 3 is 60. So 60 different ways. So what got eliminated here from the factorial? Well, originally we were multiplying by 2, and then we were multiplying by 1. But that kind of got left out of the mix this time around. So the equation for a permutation is n factorial divided by n minus r, the quantity of n minus r factorial. And that makes sense, right? So originally we had 5 factorial, which was 120, and then now we're dividing by n minus r factorial, which is 5 minus 3 is 2. 2 factorial is 2 times 1, and look at that. That's exactly what's missing. So we're just dividing out the extra ways that the other 2 spots would have provided. Combination time. So for this, it's the same scenario as for permutations, but we're gonna add one little requirement. We're going to require that different sequence does not equal a different way. Okay, so that's going to become apparent here in a second. So let's just pretend like we were doing this for the permutation. So we had 5 ways to fill the first one, times 4 ways to fill the second spot, and then 3 ways to fill the last spot. Now let's say we got our 3. So eventually we select our 3. So let's say we filled it with star, triangle, and circle. How many different sequences can we put these 3 in? Good question. Glad I asked it. Well, it'd be just like if you had 3 little spots here and you wanted to fill them with these 3 objects. Whoa! 3 times 2 times 1. So how many different sequences can you get with a set of 3? 3 factorial different sequences. So if you remember our formula for a permutation, was n factorial divided by n minus r factorial. And all we have to do for a combination is divide out our r factorial. Remember, r equals 3, so 3 factorial. So our formula for a combination is going to be slightly different. It's going to be n factorial divided by the quantity of n minus r factorial times r factorial. So you're going to divide out a little bit because you're not going to get as many different ways, because a different sequence here does not mean a different way. Just to sum up here, we had factorials, which we represented as n exclamation mark or n factorial, and then we had fewer spots to work with, so we had to divide out n minus r factorial. And then not only did we have fewer spots to work with, we also were not counting different sequences or different orders as different ways, and so we had to divide out an extra r factorial here. So this is kind of how they work. Basically, the central question, just remember the central question here is how many different ways are there to do that? And you kind of just multiply the different ways in the order that they come, and you can reference these formulas when you reach these specific scenarios. If you liked this video, definitely hit that like button. If you want to see more of these videos, send that market signal to me. Subscribe. And if you have questions, definitely leave them in the comments.